In this block of code here, we are printing some information about our waveform PyTorch tensor. So we already seen print, we already seen the f strings and string formatting. One interesting thing here is that we are using now this width here to have our numbers all nicely aligned. So if you see here, after the standard deviation, there is no space, but we are setting to the width of 5. So we have here 1, 2, 3, 4, 5, and we are setting this to all of the values, and this makes, suppose if we remove this, then we don't have nicely aligned here. But when we set this width, we have everything aligned here in this print. So there's nothing new. We've talked about string formatting before. Here we are using the f string. But what is interesting here is this waveform. So it's a PyTorch tensor, and then we have this dot max, dot min, dot standard deviation. So in the DSP theory part, we covered the mean and the standard deviation. The mean and max is quite obvious, so it takes the maximum value and the minimum value. As we mentioned before, we are loading this audio with torch load, and here it is normalizing to a float 32 tensor. So the type of this tensor is the torch float 32, and it goes from -1 to 1. So let's just create one more. As we seen before in NumPy array, also a torch tensor. So if we have our waveform, we will have many attributes and also methods. So we have max, then it returns us a tensor, and this is the value of the maximum, so it's a 1. So when we see the type of this waveform, it is a tensor. But when we take this tensor and take this item, now it becomes a float. So the type is not a torch tensor anymore. So we have this value here, which is a float. So let's take a look at item. So it returns the value of this tensor as a standard Python number. This only works for tensors with one element. For other cases, see tensor to list. And this operation is not differentiable. The item is just telling us that it will return a Python number, standard Python number, but this operation is not differentiable. So this is the only new thing we have in this block here. So we have our waveform, it's a tensor. We are taking the maximum, the minimum, the mean, the standard deviation. Then we're printing here, so we are converting this tensor to a standard Python number. So that's it for this block here.